Okay, now we are in chapter 2. Chapter 2 is about inequalities. Okay, inequalities is the symbol of inequalities is less than, greater than, less or equal, and greater or equal. Okay, so at the end of this chapter, you should be able to understand inequalities and type of inequalities, different type of inequalities, solution for finding value for inequalities, and last one is the solution for finding absolute values. So at the end of the topics, we are able to understand these three subtopics. Okay, now introduction to inequalities. So what is inequalities? So by definition, an equality is a relation between two unequal values. Okay, so the following table 1 indicates the notations and the definitions of inequalities. Okay, so now let's say we have two values which are not equal. So we want to find what is the relationship between the two values. Either they are less than, greater or equal, or less than equal. So that's form and inequality topics. Okay, now we look at the symbols of inequality. Okay, for symbol less than, so this is less than, meaning that we have two values or unknown, which is A and B. If the symbol is like A less than B, this symbol, so we read as A is less than B. Okay, for symbol greater than, so if A greater, this symbol greater than B, so we state that A is greater than B. Okay, another symbol for less or equal. If we have this symbol A less or equal B, so it means that it's either the possibilities of A and B is A is less than or equal to B. So A can take any values which is less than B, and A also can take values which is equal B. So the most value that A can take is B. Okay, because we have the sign, the equal sign here. And A cannot be more than B. Okay, for greater than or equal, so if we have this symbol, it means that A is greater than B, A is at least B. So this is another way of saying or the definition of this symbol. A is at least B. If we have a statement which is A is at least B, so we need to use this symbol. And also another definition is A is not less than B. So these three statements can use this symbol, which is A greater or equal B. Okay, for illustrations, if we have a set notation for X, whereby X greater than A, so this is in the form of set notation. Okay, in the interval notation, we have interval form. Since X is values which is greater than A, so it means that X can be any values on an interval between A to infinity. So X can be any number in between A to infinity, and A is not included. Okay, X equal A is not included since we don't have equal sign here. Okay, if we don't have equal sign here, then at the minimum value of A, we must have a closed interval. Okay, this is in interval and interval notation. For a graph notations, so we may have values from A to infinity. Infinity will be the arrow on the right side. And at point A here, there is no values of A, meaning that we have a blank dot like this, not the full dot. Okay, the blank dot indicates that A is not included. Okay, since we don't have an equal sign here. Okay, for equal sign, they do exist equal sign for values of X equal or greater than A. So we must put close interval on A and open interval on infinity. So it means that A is included since we have the closed interval and we have the equal sign on the set notation. Okay, for the graph notation, you must have a full dot here indicates that A is included in the set, and arrow on the right side indicates that values of x is greater than A. Okay, the arrow on the right side indicates that the x can take until infinite values. Okay, since x greater than A. Okay, for symbol x less than A, meaning that x does not equal A. So for interval notation, we have from minus infinity to A, and A we have a open interval since A is not included here. There is no equal sign here, so we have an open interval. And on the graph notation, starting from A, A is the largest, meaning that the smallest value is on the left side. Smallest values of x is on the left side from minus infinity. So it means that we have small values less than A on the left side. Indicates here means that the arrow goes to minus infinity. Okay, the highest values of the interval takes is A, and A is not included, so we have a blank dot here since A here is an open interval and there is no equal sign of x equal A here is not included. Okay, there is no equal sign, so on the interval notation we have an open bracket, and on the graph notation we have a blank dot like this. Okay, at the A points. Okay, another symbol for x less or equal A, like equal sign does exist here. So on the interval form, we have from minus infinity to A, and on the A side, we have a closed interval since we have equal sign here. So meaning that A is included. Okay, for graph notation, we have arrow on the left side, meaning that the values of x goes to negative infinity, and we have a full dot here because the largest value on the interval is A and A is included, equal sign. Okay, here. Okay, for interval in between, x takes values in between A and B, and there is no equal signs, meaning that A and B is not included for x values. So on the interval form, we have from A to B and open bracket since we don't have an equal sign. Okay, in between A and B, so on the graph notation, in between A and B here, so the values of x takes values on between A and B, and at A and B point, the dot is blank dot since A and B is not included in the set or on the interval. Okay, for this symbol, A in between x and B, I think this is wrong. So it should be x here, it should be A here. Okay, okay. X take values in between A and B and equal sign is included. It means that x can take A value and x also can take B value. Okay, on the interval form, we have values in between A to B, and we have a closed interval since A and B is included in the set. Okay. Okay, on the graph notation, we have values in between A to B like this, and the line is in between, line area is between A and B, and the dot at the end point, minimum and largest point, we have a full dot since A and B is included in the set form. Okay, next is linear inequalities. Okay, for linear inequalities, there are 4 types of linear inequalities. Okay, so you must understand the 4 types of linear inequalities. Okay, Okay, the standard form or the formal form for linear inequalities is written as y equal to mx plus c. This one is also known as straight line because it forms a straight line on a graph. Okay, y equal to mx plus c. Y is independent. Y is dependent variable. X is independent variable. M is slope. And C is y-intercepts. Okay. So this one must be written as AX plus B. Okay, replace M by A, replace C by B, where A and B is real numbers and A may not be 0. Okay, so this is the criteria. Okay, for a straight line graph. Okay. Four possibilities for linear inequalities are: first, we may have ax plus b, or the straight line is less than 0. Second, we may have ax plus b less or equal 0. Another possibility is ax plus b greater than 0. And the last possibility is ax plus b greater or equal 0. So now we are trying to understand these four possibilities. So this is all about solving inequalities. So we want to find out what is the possible values for x given this type of inequalities. Okay, next is solving linear inequalities. Okay, so we wanted to find values of x given these types of inequalities. Okay, operations involved in solving linear inequalities are additions and subtraction, multiplication and division, which involve positive number and negative number. Okay, same as operation in numbers, we also have operations in inequalities. Okay, first we look at addition and subtraction of linear inequalities. Okay, let's say if A is less than B, then for any values of C, we may have A plus C less than B plus C. Okay, and also we have A minus C must always be less than B minus C. Okay, for any values of A, B and C, element of real numbers. So this is always correct. Okay, given any values of C, we may have these inequalities correct. Okay. Now we solve the inequalities. Okay, given x minus 8 less than 5. So using this example, x minus 8 less than 5. So in order to get values of x only, we must add 8, positive 8 on the left side, and also at the same time add positive 8 on the right side. So we may have x minus 8 plus 8 is 0. So on the right side become 23. So the last answer would be x less than 23. So this is the standard way of solving linear inequalities. Okay. Okay, for 5x. Okay, 5x greater or equal 4x minus 2. So we may have we may have 5x minus 4x. 4x will be on the left side, so it becomes negative. 5x minus 4x greater or equal minus 2 on the right. Okay, so this become x, and the right side is minus 2. Okay, in order to check whether the answer is correct, so the values of x greater or equal minus 2 is on the right side. So starting from minus 2, where minus 2 is included here, until infinity. So on in the interval form, it is like minus 2 until infinity. On the set form, it is given by x greater or equal to. So to check whether our answer is correct, we just take values of any values in between these inequalities, x greater or equal minus 2, let's say minus 1. Okay, so or in this example, we take this example, take x equal to 2. You may also take 0, you may also take minus 1, you may also take 1, 2, 3 and so on, as long as the values of x is greater than minus 2. Right, so take 2, let's say x is 2. Okay, put in the earlier in the first equation, when x is 2, the left side is 10, and when x is 2, the right side is 6. So we have the correct answer, which is 10 greater or equal 6. Okay, next is multiplication and division by a positive number. So the next operation is multiplication and division. Okay, for A less than B, then for any multiplication of another unknown or another number, let's say C multiplied by C also always less than B multiplied by C. Or we can also have for division, for any values of real number C, A divided by C is always less than B divided by C. This is always true. Okay, example, solve the following inequalities. 6x plus 3, let's say given by less or equal to x minus 5. So we bring 2x to the left side. So collect all coefficient of x on the left side and numbers on the right side. So we have 6x minus 2x is 4x, and on the right side become minus 8, and finally minus 8 divided by 4, minus 8 here divided by 4 become minus 2. So answer for linear inequalities given by this is x less or equal minus 2. Okay. Okay, another example, 8x minus 8 greater or equal 5x plus 1. So we bring 5x to the left side, it becomes 3x. And on the right side, it become, bring minus 8 here, it become 1 plus negative. On the right side become positive, so it become 9. So 3x on the left side and 9 on the right side. So x become 9 over 3. So our last answer is 3. Okay. Okay. Next one, multiplication and division by a negative number. Earlier we have multiplication and division by a positive number. Now we have multiplication and division by a negative number. Okay, for multiplication and division by a negative number, we may change sign of inequalities. Okay, if A greater than B, then if C is negative number, okay, if C is negative number, C negative number means that C less than 0. Okay, so A multiplied by C, B multiplied by C, so the symbol is changed. Okay, we change the symbol. So it becomes, if C is negative, if multiply A, C by A, and C by B, the sign of inequality are changed into greater than. Earlier is less than. If multiplied by negative number, the sign is changed into greater than. Same also goes for division. Okay, if C is negative number, we have A divided by C. We may change the sign of the division. A less than C greater than B divided by C. Okay, for values A, B, C, element of real numbers, and C is negative. Okay. So you must remember this. We may change the sign of inequalities from less become greater, from greater also become less. If we multiply the inequalities with negative numbers. Okay, example. Solve the following inequalities. Minus 8x minus 12 less than minus 4 times x minus 4 plus 8. So solve this, the one given in bracket first. Minus 4x plus 16. Okay, and then bring all coefficient of x to the left side. So it becomes minus 4x minus 8x minus 8x plus 4x. So here is minus 4x. On the right side is 16 plus 8 plus 12. So it becomes 36. Okay, so now bring minus 4 to the right side. So we have 36 over minus 4. So we divide by negative number. So since divide by negative number, we may change the inequality sign. From less become greater than. So answer is x greater than minus 9. 36 divided by minus 4 is minus 9. Okay. Okay, next is 2 minus 12x greater than 7. Multiply by 1 minus x. Solve this one first. 7 minus 7x. 2 minus 12x. So bring all the x, coefficient of x to the left side. Minus 12x plus 7x on the left side. So it becomes minus 5x. On the right side is 7 minus 2. Okay, so we have minus 5x greater than 5. This is not, okay, this should be greater, this one should be greater, okay, this one should be greater. Okay, minus 12x plus 7x greater than 7 minus 2. So minus 5x greater than 5. So since x is on the left side, on the right side is 5 divided by minus 5. So we change the inequality. Change the equality. So from greater become less than. So answer is 5 over minus 5 is x less than minus 1. Okay, last example, 3x minus 2, 5x minus 3. So 3x minus 6, solve this first. 5x minus 3, bring 5x to the left side, it becomes 3x minus 5x. On the right side is minus 3 plus 6. Okay, so this is minus 2x less than 3. So since on the right side is divided by negative number, so we change the signs from less to greater than. So answer is x greater than negative 2. Done.